Hey everyone, welcome to Toppscholars. Today we are going to talk about a very interesting and the most easiest chapter, that is matrices. So we are going to cover matrices in one shot. I hope all of you are ready. I am excited. I hope you are excited too. So let us begin straight away without wasting any time. Let us introduce matrices first. So a matrix is a rectangular array of numbers. It's a rectangular array of numbers or functions arranged in rows and columns. So rectangular arrangement of numbers or functions arranged in rows and columns. How we'll see that? So here is the first example. Observe that we have a matrix. The name of that matrix is matrix A, right? So if you see here we have matrix A, right? Observe there are numbers arranged in rows and columns, isn't it? So here there are two rows. So horizontal are rows like this. Two rows, right? You can see 1 and 2. So you can also call this as R1, that is row 1, and this is row 2, R1 and R2. And then we have how many columns? We have 3 columns, isn't it? So you can call this as C1, C2, C3. So 2 rows and 3 columns, right? The dimensions of the resulting matrix are 2 by 3. So we read it as 2 by 3, right? Okay. So here we have one more example. That is, how many rows are there? Correct. There are 3 rows. You can see. How many columns are there? Correct. There are 3 columns. Again, you can see. Simple. So we can say that the dimensions of the resulting matrix are 3 by 3. Now let us talk about one more example. 2 rows, 2 columns, of course. So again we can say that the dimension of the resulting matrix is what? It is 2 by 2, right? Now let us talk about order of a matrix. It is very simple. Let's not waste much time on this. The order of a matrix refers to the number of rows and columns it contains. So it refers to the number of rows and columns that it contains. So if a matrix has m rows and n columns, it is said to have an order m cross n or m by n, right? Okay, let us have a look at an example. The order is always written in the form m by n or m cross n, where m is the number of rows and n is the number of columns, right? So here, how many rows are there? Very good. 3 rows. How many columns are there? 2 columns. So what will be the order? 3 rows, 2 columns. So we can say that the order is 3 cross 2, right? 3 by 2. So this is the order of the matrix. Okay. Now let us talk about the general form of a matrix. So observe. The first row and the first element is given by A11. So first row and first column. Basically this element belongs to first row and first column, right? I can say R1 and C1. So we call it as A11. So A11 is the element in the first row and first column. Similarly, if I talk about this, can I say this is the second row? The row got changed. But can I say the column is the same? So that is why it is A21. Second row, first column. So here we can say that second row, first column. So A21 is what? It is the element in the second row and first column, right? Okay. Now let's continue. Let us talk about this element. So we have A12, right? So A12 is what? This is the first row, that is R1. But this is the second column. So can I say that here first row, second column, that means A12 is the element in the first row and second column. Simple? Okay. And of course, if I take this one here, can you tell me what this is going to be? Can I say this will be A22? A22 means what? Second row, right? So this is row and second column. Simple. Let's continue. Okay, so a general M cross N matrix or M by N matrix is represented like this. So this is just the general form of the matrix A11, A12, A13, A21, A22, A23. Say we have the mth row, so AM1, AM2, AM3, so on. Correct? So this is the general form. It can be of any order, no? We can have 4 rows, 4 columns, we can have 10 rows, 15 columns, that depends. Okay. So Aij, please make a note of this. We denote it as Aij, where I is the row and J is the column. So I represents row, J represents column. So A23, that means second row, I is 2 and J is 3. Simple? Okay. So the position of an element in a matrix is represented by its row and column indices. Row and column indices. So in matrix A, the element in the ith row and jth column is written as Aij. Same thing again, just a theoretical way of saying it. Let us see an example. So here we have a matrix A and already some elements are given to us. Now observe this 2. So this 2 belongs to which row and which column? Can I say this 2 belongs to the first row and second column? So we can say A12 is 2. A12 is 2 because first row, second column, isn't it? Similarly, if I talk about 6, which is the row? Can I say this is the second row? Which is the column? Can I say third column? So here I can say that second row, third column. You can see A23 is 6, right? Okay, let's continue further. The total number of elements, very interesting, see here, the total number of elements in a matrix is given by the product. Product is what? Product means multiplication. Product of the number of rows and columns, right? So you just have to take the product of the number of rows and columns to get what? The number of elements. For example, if a matrix has an order m cross n, then the number of elements is m multiplied by n. You just have to multiply the number of elements in the row multiplied by the number of elements in the column, right? So here is an example. How many rows are there? Can I say there are 3 rows, R1, R2, R3. How many columns are there? 1, 2, 3, 4. 4 columns, right? So 3 rows, 4 columns. Then tell me how many elements are there total. The number of elements will be 3 multiplied by 4, that is 12. Simple. Okay, let's continue. So a matrix has 20 elements. The number of elements are 20 and the number of rows are 5. Determine the number of columns. Simple math. Total number of elements are given, the number of rows are given. They're supposed to find out the number of columns. So here, can I say that number of elements is nothing but number of elements in the rows multiplied by columns. Number of elements are how many? 20. Rows 5. Column is question mark. That is what we are supposed to find out, right? So we just need to divide here. So divide 20 by 5, you get 4. Can I say the number of columns are 4? Number of elements are 20. Number of rows are 5. Number of columns are 4. Simple math. Let's continue. Now have a look at this. The question says, if a matrix has 7 rows and 8 columns, 7 rows and 8 columns, how many elements does the matrix have? Simple question again. We know that the number of elements is nothing but rows multiplied by columns. How many rows are there? 7. How many columns are there? 8. Multiply it. How much is 7 into 8? 56. So yes, there are 56 elements in that particular matrix. Okay. Now let us deal with a new topic. Here we are going to talk about the different types of matrices. We need to understand the different types here. So see, what all are we going to study? So matrices come in various forms depending on their shape and the properties of the elements. Depending on the shape and the properties of their elements. You get to know what this is. So in this session, we are going to cover following types of matrices. What are they? What is the column matrix that we'll see? We'll see what is the row matrix. Then we are going to see what is the square matrix. then we will see diagonal matrix, and then we will see what is a scalar matrix. Then we will see what is identity matrix, very important because there can be questions based on this. Then we will see what is a zero matrix. So let us begin with the types of matrices now. The first type is column matrix. Column matrix. Now what does this mean? This means that a column matrix is a matrix with a single column, right? A column matrix is a matrix with a single column and multiple rows. So if there is only one column, that is a matrix having m rows and one column. This is important. It is called a column matrix. You can have a look. So this is how it will look like a vertical set of numbers, because there is only one column, that is C1. Rows can be multiple, R1, R2, R3 and so on, right? But column is one. Now tell me one thing, you have understood the definition of column matrix. Let us see an example of column matrix now. So here we have 3, 7 and 5, right? So 3, 7, 5. Can I say there is only one column? Yes. Can I say there are multiple rows? Yes. What is the order of this matrix? The order of this matrix is 3 by 1. If you see, 1 is here, that is the column. So clearly we can say that it is a column matrix. Okay. So this is 3 rows, 1 column. Okay. Now let us talk about row matrix. So what exactly is a row matrix? A row matrix is a matrix with single row and multiple columns. So if you have one row and multiple columns, it is a row matrix. So one row and n number of columns. So it will look horizontal, right? So it will look something like this. The general form is like this. A11, A12, A13, you can see only one row. The columns are more than one, right? Okay. So here is an example. So A is 1, 2, 3. So can I say there is only one row and that row is say R1. Columns are different, C1, C2, C3. So this is a row matrix with one row and 3 columns, right? Now let us talk about a different type of matrix, that is square matrix. So square matrix is a matrix with an equal number of rows and columns. That is, if the number of rows is equal to the number of columns, we call it a square matrix. So if a matrix has n rows and n columns, or m rows, m columns, x rows, x columns, just an example, it is called a square matrix. So here is the example, 4, 5, 7, 8. How many rows are there? R1, R2, 2 rows. How many columns are there? C1, C2. This is just for your understanding. You don't have to actually strike it off. So that is 2 rows, 2 columns. So we can say that this is a square matrix, right? With 2 rows and 2 columns. Simple. Now let us try to understand the meaning of a diagonal matrix. This is very important. Diagonal. I hope all of you have seen a quadrilateral, right? And this line segment is a diagonal. Similar concept we are going to use here. So diagonal matrix is a square matrix. Firstly, it is a square matrix. That means what? That means the number of rows and the number of columns must be equal. That is the first condition. So a diagonal matrix is a square matrix in which all elements except those on the leading diagonal are 0. Okay, let us see. So this is the general form. Observe. So diagonally like this, you will have some elements, but all the other elements will be 0. So let us have a look at an example to understand this better. So D1, D2, D up to Dn are diagonal elements. And that diagonal is also called as the leading diagonal. So here it is. Observe. Here we have 3. Here we have 5. The other elements are 0. So such type of matrix is called a diagonal matrix because here diagonally you have some elements. But please make a note of this. If I have something like this, now if you observe, there is one more diagonal, right? That is why leading diagonal they are saying, not for both the conditions. So this is not a diagonal matrix. Please make a note of this. Only the starting where we start from, that is A11, from that point till the end diagonally we should have numbers, others should be 0. We should not start from the second one. Fine. So this is not a diagonal matrix. Even if you take an example of 3 cross 3, there also the leading diagonal elements are some elements and the other elements are 0. Okay. So this is a diagonal matrix where the non-diagonal elements are 0. Of course, non-diagonal means other. Now let us talk about a scalar matrix. So scalar matrix is a diagonal matrix. So the condition is scalar matrix has to be diagonal matrix. That means what? The non-diagonal elements are 0 firstly, and all the diagonal elements are equal. All the diagonal elements are equal. Simple, isn't it? So for that, let us see the general form. So here it is. If you see the diagonal elements, all the diagonal elements are same, that is C. Other elements are 0. So, where C is a scalar, it is a non-zero scalar, of course, otherwise everything will become 0. So example 4004. So see, here we have 4, here also we have 4. So this is an example of a scalar matrix. I hope scalar matrix is clear to you. Okay, so this is a scalar matrix where all diagonal elements are equal to 4. Identity, that means 1, right? In mathematics, identity is generally termed as 1. So how can you define identity matrix? An identity matrix is a square matrix. It is a square matrix where all diagonal elements are 1. All the diagonal elements are 1 and all the other elements are 0. So there is a lot here. That is, the non-diagonal element should be 0 and the leading diagonal elements, they should be 1. So it is simple, isn't it? So the general form will look like this: 1, 1 and so on diagonally. Other elements are 0. And 1 is obviously a scalar value. So here it is an example 1001. Even if you take a 3 by 3 matrix 100, 010, 001, that is also an identity matrix. So this is an identity matrix of order 2 by 2. Simple? Okay. Now let us talk about zero matrix. Now come on. Looking at the name only you can identify what is a zero matrix. If all the elements in the matrix are 0, it is a zero matrix. So let us directly take an example and the general form. Everything is 0 here in the matrix. So again, order is 2 by 2 and all the elements are 0, then it is a zero matrix. So this is a zero matrix of order 2 by 2. Simple? Okay, let's continue. Now here we have an example. A matrix B is of order n by 1. Okay, there is a matrix B and the order of the matrix B is n by 1. If the sum of all elements of B is 50 and each element of B is equal, find the value of each element. We are supposed to find out the value of each element. Sum of all the elements, 50 elements, and each element of B is equal. That is, all the elements are equal. So, observe this. Firstly, we don't know the elements, right, of B. So, we are assuming let each element of B be x. Basically, here we are just supposed to find out the value of x, isn't it? So, further, the sum is given to us. Can I say, because the total elements are 50 and number of columns is already given to us, right? Sorry, number of rows is already given to us. Number of rows is already given to us. So this is nothing but your column matrix, isn't it? Because there is only one column and there are n number of rows and x is an element everywhere. Right? Because all the elements are equal. So can I say I need to add these, right? But how many rows are there? There are n rows. So I have to add x n times, right? So I'll write down nx. Correct? So nx will be equal to 50. So x will be how much? X will be 50 divided by n. Now it completely depends on n, right? It completely depends on n. So if there are, suppose, only 2 rows, then I'll divide here by 2. 50 by 2 is 25. So this will be like 25. 25. The total is 50. Suppose n is 10. That means there are 10 rows, right? And in each row, divide by 10, that becomes 5. So 5, 5, 5, 5, up to 50. Simple question, isn't it? Let's continue. Write the general form of a diagonal matrix of order 3 by 3 and provide an example. So general form of a diagonal matrix. Recall, what is a diagonal matrix? Diagonal matrix is a matrix where the non-diagonal elements are 0 and diagonal elements can be different there. So can I say, if I want to write down the general form of the diagonal matrix, it can be 3 elements A, B, C, or say D1, D2, D3, which is nothing but, let us make this D3. So D1, D2 and D3, 3 different elements, and all the other elements are 0. So this is the general form. Give an example. So we can give an example also. That is 3 minus 2, 5. You can take negative, you can take positive, you can take any real number here. Doesn't really matter. So 3 minus 2 and 5 in the place of diagonal. I hope this is clear. Now let us talk about equality of matrices. So when are two matrices equal? Very important two conditions are there for the matrices to be equal. So two matrices A and B are said to be equal if they have the same order. That is, the order of both the matrices must be same. If the first matrix has the order 2 by 2, the second matrix should also have the order 2 by 2. If it is 3 by 2 for the first, it should be 3 by 2 for the second. But that is not enough, right? Equal corresponding elements, very important. Each element of A must be equal to the corresponding element of B. Corresponding is also important. So each element of A must be equal to corresponding element of B. Then only the two matrices are said to be equal. So let us see an example. Here we have A as 1, 2, 3, 4, 5, 6. There are 2 rows, 3 columns. Here we have B 1, 2, 3, 4, 5, 6. Can I say the order of the first matrix is what? What is the order 2 rows, 3 columns? What is the order of the second matrix? 2 rows, 3 columns. Okay, order is same, yes, but what about the corresponding elements? Let us check 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6 and 6. This is called corresponding elements. We cannot have the terms to be shuffled here. So yes, this is an example of two matrices being equal. So since both the matrices have the same order 2 by 3 and the corresponding elements are equal, we can say that the matrices A and B are equal, right? Now if two matrices do not satisfy, then we can say that not same order, that is they don't have the same order, or they can have unequal corresponding elements. For example, there are two matrices with different orders. We'll see that example here. A is 1, 2, 3, 4. Okay, how many rows are there? 1 row. So this is 1 row. How many columns are there? 1, 2, 3, 4. Okay. Then we have B. How many rows are there? 2 rows. How many columns are there? 2 columns. So can I say both of them are equal? No, because their order is different. So we can say that the order is 1 cross 4 and there the order is 2 cross 2 or 2 by 2 you can say. The order of A and the order of B, they are not equal. Therefore, we can say that these two matrices are not equal. The order is not same. Right? A is not equal to B. Now let us see what happens when we have unequal elements. So here we have A. Suppose the order is same. See, this is a matrix of order 2 by 2. This is a matrix of order 2 by 2. Now let us check the corresponding elements. Here we have 2. Here we have 2. Okay. Here we have 3. Here we have 3. Okay. Here we have 4. Here we have 4. Okay. But here we have 5 and here we have 6. They are not equal, right? So even if one element is different, they are not equal. So we can say that here both the matrices have same order, of course, but the element at position 2, 2 differs, right? Because 5 is not equal to 6. And therefore, we can say that A is not equal to B because 5 is not equal to 6. Simple? Okay. Now let us see an example. Consider solving for x and y in the following matrix equality. Okay. We are supposed to find out the value of x and y. It is very simple. it is already given. What is given to us? It is already given that the two matrices are equal. We are just supposed to find out the value of x and y. So what we will do? We know that two matrices are equal, then their corresponding elements are also equal. So here check, x will be equal to 2, right? And y with the corresponding element, that is 5. So y will be equal to 5. So the value of x is 2 and the value of y is 5. Simple. Just compare carefully, one-to-one correspondence. Their positions are very important. Okay. Let us see an example. If the matrices, this is the first matrix A, we have 2x, 3y, z and 4. And we have the second matrix B, 8, 9, 5 and 4. 2x, 3y, z, 4. Then we have 8, 9, 5, 4. The question says they are equal. It is given. They are equal. Find the values of x, y and z. Now 3 values we are supposed to find out. It's very simple. See the position here. The first element of A and the first element of B will equate that, right? So here we are going to say that 2x is equal to 8. Simple. So x will be what? 8 divided by 2. The value of x will be 4. Now check there. 3y and 9. So can I say, going further, 3y will be equal to 9? Yes. So what will be y? Y will be 9 by 3. That is 3. And for z, we'll get it directly, right? Z is 5. You don't have to solve anything there. The value of z is directly 5. And of course, this 4 and 4. There also it should be equal, right? So anyways, it was given in the question. So yes, we got the value of x, y and z. That is 4, 3 and 5. Clear? Let's continue. That's it. Hey everyone, so we have a new question. It says, for what values of k does the matrix A is equal to kx, 3, y, 2k equal to the matrix 15, 3, 5 and 10. So firstly, you see there are 3 unknowns here. We have kx, we have y, we have 2k. It's very simple. Firstly, if we focus on kx and 15, we can say that kx is equal to 15, right? Then further, if you go ahead, x will be what? Or you can say k will be what? 15 by x. We can mark this as equation number 1. Now, change your focus to y. Y directly we know how much is y. Y is equal to 5. This is our equation number 2. Observe the last one, that is 2k. Can I say 2k will be equal to 10? Clearly, what will be the value of k? The value of k will be 10 divided by 2, that is 5. Now the value of k is 5. If I put the value of k over here, so further if I solve that, value of k as 5, so x will go there, 5 will come down, x will be equal to how much? 3, right? The value of x will be 3. But does this satisfy the value of k as 5? Let us check. K into x. K into x. K is how much? K is 5. X is how much? X is, we got the value of x as 3. 5 into 3 is how much? 5 into 3 is 15. Check your B matrix. Is it 15? Yes. That means our value of k, which is 5, that is 2k is equal to 10, that k is 5 is correct. We have to verify it here also, because directly don't write down 2k is equal to 10 and k is equal to 5. This should also get satisfied, right? So just check that once. Okay. Now let us talk about the different operations on matrices. So when I say operations, I'm talking about addition of matrices, then I'm talking about subtraction of two matrices, maybe 2 or more than 2 matrices. I'm talking about multiplication also in this case. So let us deal with the operations one by one. So here basic operations include the addition of matrices, difference of matrices, that is subtraction, multiplication of a matrix by a scalar, that is we'll see how to multiply the entire matrix by a single non-zero number, and then multiplication of matrices. We'll see how to multiply the actual 2 matrices here. So 2 matrices, there is a condition, there is some rule, right? In arithmetic also there are rules while adding numbers. Here also there is some rule when it comes to addition of 2 matrices. So 2 matrices can be added only if they have same order. If the order is same, that is only one condition. If the order is same, you can add the matrices. Same number of rows and columns, of course. That is the meaning of order, right? So addition of matrix is not possible when the order is different. So suppose if I have a matrix A, if I have a matrix B, and I am willing to add both of them, but I can't, because here there are 2 rows and 3 columns, and here there are 2 rows and 2 columns. So the addition is not possible. Alright. So 2 rows, 3 columns, 2 rows, 2 columns. Yes. Not same order. So we cannot add them. Okay. So when can we add? We can add like this. If we have 2 matrices, we're going to check whether addition is possible or not. Here the first matrix has the order 2 rows, 2 columns. Now the second matrix has the order 2 rows, 2 columns. Same order. So yes, we can add them. Yes, the answer is, can we add? Yes. But how to add? Let us see that. So basically we are seeing an example that whether the addition of matrices is possible or not, and then also find the addition. So matrix A is given, matrix B is given. What is the condition to check whether addition is possible or not? The order. So let us see the order. Order is same. This is 2 cross 2, this is 2 cross 2. Addition is possible. So we can add them. Now how do we add them? To add the matrices, we add the corresponding elements. That is, from here A11, because that is matrix A, and from matrix B, say B11. I'm calling it as B11. So A11 and B11 will add together. That is 1 plus 5. Then if I change this, A12, B12, add them together, write it in their corresponding position only. Then 3 and 7, and then finally 3 and 8, right? So just take the addition. 1 plus 5 is 6, 2 plus 6 is 8, 7 plus 3 is 10, and 8 plus 3 is 11. So the addition is here. This is very simple and straightforward. Basic addition, right? Let's continue. Now let us talk about some properties of matrices. The first property is the commutative property. Commutative property, like commutativity of numbers. If you add 2 numbers, A and B, and then you add B and A, you get the same answer, right? 2 plus 3 is 5, 3 plus 2 is 5. Same logic is applied in matrices as well. So, if A and B are 2 different matrices, if you add A and B and you add B and A, you will get both of them equal, right? Associativity, same thing. The order in which the addition you do does not matter for 3 matrices. So, if A, B and C are 3 different matrices, you add A and B first, get the result, then add C. Or you add B and C first, then add A, you'll get the same result. So yes, associativity exists for addition. The existence of additive identity, that is, this is very simple, additive identity. In lower grades also, remember, if we add 0 to any number, we get the same number, right? That is 5 plus 0 is 5, 10 plus 0 is 10. Here also, if you add a 0 matrix to a matrix, you get the same matrix, right? Let us see how. Take any matrix 2, 3, 4, 2 and add 0, 0, 0, 0. It is going to be 2, 3, 4, 2 only, right? You can imagine that as well. Okay. So existence of additive inverse. Now understand, if I have a matrix A and if I have a negative of matrix A, if I add both of them, then A and negative A are additive inverse of each other, which gives me a 0 matrix. So if I have 2, 3, 4, 5 as A, and I have minus 2, minus 3, minus 4, minus 5 as my other matrix. If I add both of them, 2 minus 2, 3 minus 3, 4 minus 4, 5 minus 5, everything will get cancelled. You will get 0, 0, 0, 0. So A and the other matrix, if I call it as B also, A and B are inverse of each other. That B is nothing but minus A, negative of A, right? Okay. Now difference of matrices, again very important. The difference of 2 matrices A and B, both having the same order. Again, if you want to subtract the 2 matrices, the order has to be the same. The order should not change. Is obtained by subtracting corresponding elements. So, corresponding elements, you just have to subtract them, order should be same. So, basically we can say that A minus B is given by Aij minus Bij. That is I and j, if you remember, recall it, they are nothing but rows and columns. So properties, it is not commutative. That is A minus B is never equal to B minus A. Always remember, A minus B and B minus A are two different matrices. They are not equal. Then A minus A is always 0. That's obvious. If you subtract, even in numbers, if you subtract two same numbers, you get 0, right? So two matrices, if you subtract, you'll get a 0 matrix basically, not a number now. So let us talk about multiplication now. Subtraction is done. Multiplying a matrix A by a scalar K. Scalar is any number basically. Generally we take a non-zero number here. Directly we cannot multiply 0 to any random matrix basically. So meaning multiplying each element of A by K. Okay. So A is what? A is a matrix and K is what? K is a scalar. So this is a scalar and this is actually the matrix. That gives you K times Aij. So K goes inside and gets multiplied with every element of the matrix, right? So let us see an example. So suppose if matrix A is given and the scalar K is given, I need to find K and A. I need to multiply both of them. So my K here is 3, right? So I'll multiply 3 to this matrix, but this 3 is not multiplied to only one element. It is multiplied to every element. So 3 will be multiplied with 2, with 3, with 4, with 1, everyone. So here 3 into 2, 3 into 3, 3 into 4 and 3 into 1. And the final answer that you get is 6, 9, 12, 3. I hope this is clear that the scalar is multiplied to each and every element of that particular matrix. Okay, let's continue. Now let us talk about distributivity over matrix addition. Now, if there is an addition of two matrices A and B, you add both of them and then multiply the addition by K, any non-zero scalar. That will be same as K times matrix A plus K times matrix B, right? Simple logic. Distributivity over scalar addition, that is K plus I times A is equal to K times A scalar addition. It's the same thing. K plus I times A is equal to K times A plus I times A. Now let us talk about associativity of scalar multiplication. So K times IA is same as K times I times A, right? So if you multiply an identity matrix with A, or you multiply the scalar and the identity and then with A, you're going to get the same answer. Multiplicative identity, that is 1. 1 is nothing but I here. Basically instead of 1, we write I. I is nothing but the identity matrix. And if you recall, you have studied about the identity matrix, right? It's something like this, 1, 0, 0, 1. So this identity matrix acts like our 1 in matrices, such as 5 multiplied by 1 is 5. This is in numbers, right? But if you take a matrix, say 3, 2, 1, 5, and you multiply this with 1, but 1 is nothing but I here, that is 1, 0, 0, 1. So this is like your 1. You get the same answer as in this one. 3, 2, 1 and 5. But how do we multiply that? We are going to see in the multiplication of matrices, of course. So here, this is like your I, right? I hope this part is clear. Okay, let's continue further. Negative of a matrix. It's very simple. The negative of a matrix A, if you have a matrix A, the negative is denoted by minus A. And is the matrix obtained by multiplying every element of A by minus 1. So every element you will multiply by minus 1, right? The scalar K here is minus 1. So minus 1 times A is basically your negative of a matrix. Like this. So A is Aij minus A is minus of Aij. So here we have an example. A is 2 minus 3, 4, 1. Now if I need minus A, this 2 will become minus 2, 4 will become minus 4, but minus 3 will become 3 and 1 will become minus 1. I hope this is clear, simple, right? So adding a matrix and its negative always results in a zero matrix. Very important. Obviously, because if you add both of them here, what will happen? If you add these two matrices, this is A, this is negative of A. If I add them, 2 and minus 2, 0, minus 3, 3, 0, 4 minus 4, 0, 1 minus 1, 0. Now comes a very important topic, that is multiplication of two matrices. We are going to see how do we multiply two matrices now. So the definition says the multiplication of two matrices A and B is defined only if the number of columns of matrix A, number of columns of matrix A is equal to the number of rows of matrix B. So if the number of columns of matrix A is equal to the number of rows of matrix B, then only the multiplication is possible. If A is of order m cross n and B is of order n cross P, then the product of AB is m cross P or m by P. Let us understand this. Observe very carefully. Understand the condition there. The condition says that, now suppose I have a matrix, matrix A, and the order of that matrix is 3 by 2. Now see, the multiplication of two matrices A and B is defined only if the number of columns of matrix A, how many columns are there? The columns are 2, is equal to number of rows of matrix B. I have a matrix B. Suppose the order is 3 by 1. Now tell me, how many rows are there here in B? 3. How many columns are there in A? 2. Is 2 and 3 same? No. 2 is not equal to 3. If 2 is not equal to 3, we cannot multiply A and B. The multiplication of A and B is not possible. So, observe here. If the matrix has the order m cross n and the other matrix has the order n cross p, so if this is n, this has to be n. And what is the final output? The final result is m cross p, that is the product is m cross p. Let us have a look at this example. So here, firstly notice, hold on, here how many rows and columns are there? Can I say here, there are 2 rows and 3 columns, 2 rows, 3 columns, correct? How many rows and columns are here? Here, there are 3 rows and 2 columns. So tell me, this is 3, this is 3. Is it equal? Yes, it is equal. So multiplication is possible. And the result is going to be 2 cross 2. What is the result going to be? 2 cross 2. So let us see, how do we multiply? Whenever we multiply the first row with first column. So, first row, first column. But how? Am I going to multiply one with everyone? No. First element with first element. Second element with second element. Third element with third element and add them. So, 1 multiplied by 7 plus 2 multiplied by 9 plus 3 multiplied by 11. We get 58. So, we will write down 58 in this particular position. That is 58. Now, this is done. Now, what we will do is, we will take the first row and second column. Same thing. 1 with 8, 2 with 10, 3 with 12. 1 8s are, 2 10s are, 3 12s are. You get 64. Write it here 64. Now, second row, first column. Take the second row, first column, corresponding elements 4, 7, 5, 9, 6, 11. Multiply. The final answer is 139. Write it here 139. And then second row, second column. Second row, second column. Correct. 4 into 8, 5 into 10, 6 into 12. 154. Write it here. Now see how many rows are there? There are 2 rows. How many columns are there? There are 2 columns. So can I say this is like M cross P because this has 2 rows and this has 2 columns. So the final output that we get is 2 cross 2. I hope you have understood how to multiply 2 matrices. Now let us see about the properties of matrix multiplication. So firstly we are talking about the associative property. So if B and C are 2 matrices, if you multiply them and then you multiply A with the product of B and C, that is equal to A multiplied by B multiplied by C. Now let us talk about distributivity. That is, if you have 2 matrices B and C and you add them and then you multiply a matrix A with B plus C, then A multiplied by B plus A multiplied by C will be equal to A times B plus C. Always remember that A multiplied by B, that is matrix A multiplied by matrix B, is never equal to, in general, matrix B multiplied by A. This is not like your general numbers like 5 into 2 is 10, 2 into 5 is 10, right? But in this case, if you multiply 2 matrices, AB and BA are generally different. Always remember that. Identity matrix. For any matrix A, the matrix multiplied by I, that is the identity matrix, and the identity matrix multiplied by A is always equal to A. So this is what we are supposed to remember. So I is like your 1 basically here. That is the identity matrix. And you multiply a matrix A with the identity matrix, you are going to get the same matrix. Now let us see some special cases. Zero matrix multiplication. So if A is any matrix and 0 is a 0 matrix, O is a 0 matrix basically, of the appropriate dimensions, that is, it should match with the multiplication should actually exist, right? Then we can say that the product of the 2 matrices is always 0. Obviously, even if I take about the number 0, 0 multiplied by any number is 0, right? So here also, if matrix O is a 0 matrix and A is any scalar matrix, not necessarily scalar matrix, A is any matrix, then O multiplied by A is always a 0 matrix only. So here is an example. We have matrix A as 1, 2, 3, 4. We have matrix O as 0, 0, 0, 0. When you take the product, you will always get 0, right? Because even if I multiply the first row with first column, 1 into 0 is 0, 2 into 0 is 0. If I add them, I am going to get 0 and so on. You know how to multiply that, right? Okay. Now let us see an example. Find the product AB and BA. Are AB and BA equal? So A is given, B is also given. Firstly, we'll find out the product AB, then we'll find out the product of BA, and then we will check whether they are equal or not. So let us begin. So let us talk about AB. We know how to multiply, right? 1 will be multiplied with 5, 2 will be multiplied with 7, and we write it here. 1 multiplied by 5 plus 2 multiplied by 7. Then for the second element, what are we going to do? 1 multiplied by 6 and 2 multiplied by 8. Then 3 multiplied by 5 and 4 multiplied by 7 here. 3 multiplied by 6, 4 multiplied by 8 here. Correct. If you solve this further, you are going to get 19, 22, 43, 50. So we have just solved this and added. So AB is 19, 22, 43, 50. Now let us talk about BA. So BA is B times A. So this will be your first row and this will be your first column, right? So 5 multiplied by 1 and 6 multiplied by 3 will come here. Then first row, second column. 5 multiplied by 2 and 6 multiplied by 4. Then second row, first column. 7 multiplied by 1 and 8 multiplied by 3. Second row, second column. 7 multiplied by 2 and 8 multiplied by 4. Corresponding elements. And you check, it is finally 23, 34, 31, 46. That is the product of BA. But if you see very carefully, what was AB? AB was 19, 22, 43, 50. And BA is 23, 34, 31, 46. So are both of them equal? Definitely not equal. We are not getting the same matrices, right? So we can say that they are not equal. AB is not equal to BA. Now let us see an example. So if A is 1, 2, 3, 4 and B is 5, 6, 7, 8, calculate A plus B minus A minus B. It's very simple. Firstly, addition is possible because both the matrices have the same order. So we will find A plus B, get the answer, we'll find A minus B, get the answer, and then subtract them, right? So that's what we are going to do. So here it is. Firstly, calculate A plus B. So A plus B, how do we add them? The corresponding elements, 1 will be added with 5, 2 goes with 6, 3 goes with 7, and 4 goes with 8. Correct? Add them. 1 plus 5 is 6, 2 plus 6 is 8, 3 plus 7 is 10, 4 plus 8 is 12. We get A plus B. Now let us talk about A minus B. A minus B is you are supposed to subtract the corresponding elements here. So we'll subtract 1 and 5. Then we'll subtract 2 and 6. Then we'll subtract 3 and 7. Finally, we'll subtract 4 and 8. Clear? What are we going to get? Minus 4, minus 4, minus 4, minus 4. Okay. This is A minus B. We calculated this, we calculated this. Now we will subtract both of them. So the next step, that is step 3, is calculate A plus B minus A minus B. A plus B, if you remember, it is 6, 10, 8, 12. A minus B is minus 4, minus 4, minus 4, minus 4. Now this is like your minus 1, right? So you multiply minus 1 inside. What do you get? That is, you will multiply minus with every element here. See, minus 4, minus 4, minus 4, and minus is there. That will become plus, no? And then you are going to get 6 plus 4, 10, 8 plus 4, 12, 10 plus 4, 14, 12 plus 4, 16. Clear? Now let us talk about transpose of matrix. The transpose of a matrix is obtained by interchanging its rows and columns. So when do we get the transpose of a matrix? When we interchange the rows and columns. Rows becomes column, columns becomes row. So if A is a matrix of order m cross n, its transpose is denoted by A, and we write down T at the top, that is A transpose, or simply we write down A dash. So A dash is nothing but the transpose, and it will have the order n by m. Obviously, m rows will become n columns will become m, right? So rows are interchanging with columns. So let us have a look at an example and also the general form how we write it. Mathematically, if A is a matrix whose elements are Aij, then the transpose of A, that is A transpose, becomes the elements Aj, I becomes J, J becomes I, right? So let us see some properties of transpose. So transpose of a matrix, the example now, find the transpose of the matrix A, 1, 2, 3, 4, 5, 6. So how many rows are there? Can I say there are 2 rows? R1, R2. Can I say there are 3 columns? C1, C2, C3. So rows becomes column, columns becomes row. So first row will become first column, right? And second row will become second column. So the transpose will be first row. This is the row. 1, 2, 3. Write it down in column. So that becomes your 1, 2, 3, right? And then second row becomes second column. That is 4, 5, 6. If you see, now how many rows are there? There are 3 rows. How many columns are there? There are 2 columns, C1 and C2. Here we had 3 columns, here we have 2 columns. Here we have 2 rows, here we have 3 rows. Simple? Okay. Now understand that transpose of A transpose is A. That means if you have a particular matrix, you take the transpose and then again you take the transpose, you again get A. So the transpose of a matrix is the original matrix, right? Second property, A plus B transpose. So if you add the 2 matrices and then if you take the transpose, that will be equal to A transpose plus B transpose. The transpose of the sum of two matrices is the sum of their transposes, right? Now property 3, AB transpose, that is if you multiply the two matrices and then take the transpose. Now this is very important, there can be problems based on this. That is equal to B transpose multiplied by A transpose. Remember that AB transpose is not equal to A transpose B transpose. It's B transpose A transpose. So this and this is different. Okay, let's continue further. So if we have a scalar k and you multiply k with A transpose, that is same as you multiply k with A, that is the matrix, and then take the transpose, you will get the same answer. So the transpose of a scalar multiple of a matrix is equal to the scalar multiplied by the transpose of the matrix. Simple. Now let us see some examples verifying the property for AB transpose is equal to B transpose times A transpose. So here we have A, which is 1, 2, 3, 4. Here we have B, which is 5, 6, 7, 8. What are we supposed to verify? We are supposed to verify that AB transpose is equal to B transpose times A transpose. So AB transpose, for that we need to multiply A and B. So let us begin. This is A, this is B. So AB, A and B, we are multiplying. We know how to multiply. First row, first column, second row, second column, right? So after multiplying, what are you getting? You're getting this 19, 22, 43, 50. That is the product of the matrices A and B. Now we need to take the transpose. How do we take the transpose? This first row will become first column and second row will become second column, right? So let us take the transpose. So AB transpose will be 1943 becomes first row and then 2250 becomes second row, correct? So this is our first first equation, you can say. Now we need to take B transpose A transpose. So let us begin. So B transpose, that is transpose of B, 5, 6, 7, 8. So 5, 6 becomes first column, 7, 8 becomes second column. Then A transpose, what is A transpose? That is 1, 2 becomes first column, 3, 4 becomes second column, right? I hope this is clear, there is no confusion. Now B transpose A transpose, what is the meaning of that? Meaning is we need to multiply both of them. Let's multiply. So B transpose multiplied by A transpose, that is 5, 6, 7, 8 multiplied by 1, 2, 3, 4. 1, 2, 3, 4 like this, or 1, 3, 2, 4. Now multiply this 5, 1, 7, 2. That is 5 1s are 5, 7 2s are 14, 5 3s are 15, 7 4s are 28, 8 2s are 12, 6 3s are 18 and 8 4s are 32. Now see what you are getting, 19, 43, 22, 50. Does this match with AB transpose? Yes. So we can say that AB transpose is equal to B transpose times A transpose. I hope this part is clear. Now let us see some different types of matrices. That is, what is a symmetric matrix and what is a skew symmetric matrix. So symmetry, I hope you know the meaning of symmetry, right? In general. So a matrix A is said to be symmetric if the transpose and the matrix are equal. That is, if you have a matrix, you take the transpose and still if you get the same matrix, it is said to be symmetric matrix. For an example, if A is 1, 2, 2, 4, right? Now you take A transpose, that is, take first row as first column. So first row is 1, 2, that becomes first column 1, 2. Second row is 2, 4, that becomes second column 2, 4. Same thing, isn't it? So can I say A transpose and A, both of them are equal? Yes. So this is definitely an example of a symmetric matrix, right? So A is equal to A transpose. So A is a symmetric matrix. A matrix A is said to be skew symmetric if A transpose is equal to negative A. So I'll give you a simple example here. Now observe, here we have A as 0, 2, minus 2, 0, right? Now what I'm doing is, firstly let me take A transpose. What will be A transpose here? First row will become first column, right? So 0, 2. That will become first column, that is 0 and 2. And second row will become second column, that is -2 and 0. Now tell me one thing, observe very carefully. If I take minus sign outside, if I take this minus outside, what will remain? I will have 0, this is 2, this will become -2 because -2 into -1 is 2 and this will become 0. But what is this? Can I say this matrix is nothing but A? So instead of this matrix, can I write down A? So this will be equal to, minus sign is there and A is there. So see, A transpose is equal to minus A. So if you get such a condition, we can say that this is a skew symmetric matrix. Clear? Let's continue. Now determine whether the following matrix is symmetric or skew symmetric. This is the question. So here is a matrix and we are supposed to identify whether this is a symmetric matrix or a skew symmetric matrix. So this is a 3 by 3 matrix. Now firstly let me take A transpose. So first row becomes first column, second row becomes second column, third row becomes third column. Now observe, 0 is 0, but 3 is becoming -3, -1 is becoming 1, right? -3 becomes 3, 2 is -2, 1 -1, -2, 2. So the signs are opposite. So can I say this is like your -A, right? -A, isn't it? So this is -A. And we know that if A transpose is equal to -A, then clearly this is a skew symmetric matrix. I hope this is clear to you. So it is a skew symmetric matrix. Now comes a very important topic, that is invertible matrix. So we are going to see when is the matrix invertible, what are the conditions, and how do we actually find out the inverse of a matrix, and what is the meaning of inverse. So a square matrix A is said to be invertible if there exists another matrix B. Square matrix A is said to be invertible if there exists another matrix B such that if you take the product of AB or you take the product BA, that gives you I, that gives you the identity matrix. After the multiplication, if you get identity matrix, we can say that the two matrices are what? Inverse of each other. I hope this part is clear. Now, I is the identity matrix of the same order, right? Now the matrix B is called the inverse of A and it is denoted as A inverse. So matrix B is denoted by A inverse, right? Matrix B. So I can also write down like this, that A multiplied by A inverse, or if I write down A inverse multiplied by A, and both of them are going to give you I, right? That is the identity matrix. Okay, let's continue. So only square matrices can have inverse. So only square matrices have inverse. So if the order of the matrix is m cross n, where m and n are not equal, you cannot find the inverse of that. So here is the matrix A and here is matrix B. So matrices with the same number of rows and columns are called square matrices. So this has order 2 cross 2, this has order 3 cross 3. So order has to be same, then only you can take the inverse, otherwise not. Now let us begin with a new concept, that is to find the determinant of a matrix. To find the determinant of a matrix, that is a 2 by 2 matrix. Suppose we have a matrix A, B, C, D, and we are supposed to find out the determinant of this. How do we do that? Determinant of A, it is denoted as like this, or in simple terms, generally we use this one, that is we write down two lines and A in the middle. That is, determinant of A is given by A multiplied by B, that is, we will multiply the elements in the diagonal, that is the leading diagonal, then you will multiply the elements in the other diagonal, that is B and C, and then subtract them. I hope this is clear. So AB minus BC is nothing but the determinant of A. So let us see here. Let us see an example. So if we have A, which is 2, 1, 2, 3, and we are supposed to find out the determinant of A, then determinant of A is given by 2 multiplied by 3 minus 2 multiplied by 1. 2 multiplied by 3 is 6. 2 multiplied by 1 is nothing but 2. 6 minus 2 is 4. So the determinant is 4. I hope you are clear how to find out the determinant of a 2 by 2 matrix. Now, let us see how to find out the adjoint of a 2 by 2 matrix. Adjoint of 2 by 2 matrix. So find the adjoint of a matrix. How do we do that? To find the adjoint of a matrix, interchange the elements of principal diagonal and just change, but do not interchange, the signs of the elements of the other diagonal. So two conditions. Condition 1, interchange the elements of the principal diagonal and change the signs of the elements of the other diagonal. Let us see this with the help of an example. Theoretically it looks difficult, but it is very simple. So matrix A is given, A, B, C, D. Now here what are we going to do? We are going to interchange the elements of the principal diagonal, that is the principal diagonal is nothing but the leading diagonal here, A and D. Interchange. So what will happen? D will go at the place of A and A will come at the place of D. And for the other two, that is non-leading diagonal, you change the sign. That is, don't change B and C there, interchange, just change the sign. Make this as minus, make this as minus if it is plus. If it is minus, make it plus. Okay. So change signs. So observe, D and A. D, A. Position interchanged. B and C. Position is not interchanged, but sign is given. So that is how you find out adjoint of a 2 by 2 matrix. I hope this is clear. Okay. So for a 2 by 2 matrix, A is given. The inverse of matrix A. How do we find out the inverse? That is what we are going to study now. Forget about adjoint. Now we are going to talk about the formula for inverse of a matrix. And why did we study adjoint? Because you are going to have adjoint and the determinant in these questions. So the inverse of matrix A is given by A inverse is 1 by determinant of A, and you just have to interchange this. So if you remember, we need adjoint, right? So the formula is 1 by determinant of A multiplied by adjoint of A. So you need to find out the determinant, you need to find out the adjoint, take 1 by determinant, take the adjoint and multiply this particular scalar with the matrix, you will get your inverse. Let us see this. So find the inverse of the matrix. Two things. First is determinant. So firstly, if I consider this matrix as say matrix A, can you find out the determinant? Calculate determinant. How? We know. We just have to cross multiply kind of and then take a minus sign in the middle, subtract them. So here the determinant will be 2 multiplied by 4 minus 3 multiplied by 1. That is 8 minus 3, that is 5. We got the determinant, so we got this value. Now we need to take what? This part, that is adjoint. How do we do adjoint? We interchange 2 and 4 and we change the sign of 1 and 3. And also, one important thing to note here is that inverse is possible. Please make a note of this. Inverse is possible only when the determinant is not 0. If the determinant is 0, we cannot take the inverse of a matrix. Now you ask me why? Because see the formula, 1 by determinant of A. What will happen if I get the determinant as 0? It will become 1 by 0. 1 by 0 is not defined. Then I can never get A inverse, right? So to get A inverse, determinant should not be 0. Negative is fine, positive is fine. Okay. So it is 5 and we know that 5 is not equal to 0. So inverse exists. And let me go to the previous slide because this is the question. So here, if you see, I'm going to interchange, right? 4 I'll write here, 2 I will write here. I'll write 1, I'll write 3, but give minus sign to both of them. Correct? Not only that, here if you notice, I have 1 by 5, right? Because the determinant is 5. Now 1 by 5 is a scalar, multiplied inside. So further, if you see this, 1 by 5, so 5 will basically go to the denominator of every term. So that further becomes, this will become 4 by 5, this will become minus 1 by 5, minus 3 by 5 and 2 by 5. That's it. That is your inverse. I hope this question is clear to you. Okay. Now properties of inverse. The inverse of A inverse will give you the matrix A. So if you take the inverse of A inverse, you are going to get the same matrix A. The inverse of a matrix is the matrix itself, right? Second property, AB inverse. If you multiply the two matrices and take the inverse, that is same as B inverse multiplied by A inverse. Clear? The inverse of the product of two matrices is the product of their inverses in reverse order. Reverse order. It is not A inverse multiplied by B inverse. It is B inverse multiplied by A inverse. Property 3. So if you multiply a scalar with a matrix A and then take the inverse, that is same as you take out the scalar and then you multiply A inverse, where K is non-zero. Obviously, K has to be non-zero here. The inverse of a scalar of a matrix is the scalar inverse 1 by K multiplied by the inverse of a matrix. I hope this is clear. Property 4, the inverse of A transpose, right, is equal to A inverse transpose. That is, you take A transpose and then take the inverse, or you take A inverse then take the transpose. This is basically here minus 1. Then in that case also we are going to get the same answer. So verify the property. AB inverse is equal to B inverse multiplied by A inverse. Let us see what is A and B. So A is 1, 2, 0, 1. We are supposed to verify that AB inverse is B inverse multiplied by A inverse. And B is also given 3, 1, 2, 1. Firstly, let us take AB. AB is what? A multiplied by B. So step 1 is finding AB. So A and B we are multiplying. We know how to multiply first row, first column, second row, second column, right? Then second row, first column, second row, second column. So let us do that. Directly we have got the answer. What is AB? 7, 3, 2, 1. Now we need to take the inverse. To take the inverse, what all do we need? We need the determinant. We need the adjoint. So let us take the determinant further. So determinant we need to calculate. Directly we are doing it. Determinant for AB. So if you see what was AB? AB was 7, 3, 2, 1. So 7 multiplied by 1, 3 multiplied by 2. We'll subtract that. See here. 7 multiplied by 1, 3 multiplied by 2. Correct? And then here we'll just interchange 1 and 7 and take the minus signs. Solve this further. This becomes 7 1 the 7, 3 2 the 6. So anyway it is 1 outside. That is gone. This is AB inverse. Please make a note of this because we are going to solve for B inverse, A inverse also. So now we'll find out B inverse. Only focus on B. B inverse is what? 1 by determinant of B. Then 1 will go here, 3 will come down, minus 1, minus 2 will become here. Determinant of B. 3 ones are and 2 ones are. That comes here. 3 ones are 3, 2 ones are 2. Interchanging positions, changing the signs. So as of now, B inverse is 1, minus 1, minus 2, 3. Okay. Now we need to calculate A inverse. So let us go ahead with calculating A inverse. So here it is. A inverse is what? 1 by determinant of A. Interchanging the positions, changing the signs. Determinant of A, 1 ones are and 2 zeros are. 1 ones are, 2 zeros are. 1 ones are 1, 2 zeros are 0. So again outside we are going to get 1. Ignore that. 1 1. Even if we change the position, it is going to be 1 1. Change the signs. So we have 1 minus 2, 0 and 1. This is your A inverse. Now we will take B inverse multiplied by A inverse. So let us do that. Here it is. So this is B inverse. This is A inverse. We multiply 1 with 1, minus 1 with 0 and so on. You know the procedure. So this is 1 plus 0, then minus 2, minus 1, then we have minus 2 plus 0, and then minus 2 is 4, and plus 3. So what is the final answer? 1 minus 3 minus 2, 7. This is B inverse A inverse. But what was AB? If you recall, AB was also this. Yes. So we can say that AB inverse is equal to B inverse multiplied by A inverse. I hope this is clear to all of you. So the inverse of a matrix can also be found using elementary row operations. Now let us try to understand what this elementary row operation exactly is and how do we apply that on the problems. So to find out A inverse using row operations, firstly we write A as AI, because AI is A only, no? Like I is like your 1. If I say 5 multiplied by 1, it's 5 only. 7 multiplied by 1, it is 7 only. So AI is like your A, doesn't matter, where I is the identity matrix of the same order. So if A is of the order 2 by 2, I is also of the order 2 by 2, right? Okay. Then perform row operations. We are going to do some operations on A to convert it into I. So what we are going to do is, we'll do some operations like addition, subtraction, multiplication, division, depending on the requirement to convert it into I, to convert it into the identity matrix. How we'll see that? Then apply the same on I. Whatever you are doing on A, whatever operation you do on A, you apply the same operation on I. Then what happens is, this A gets converted to I, and this I gets converted to some matrix. That matrix is nothing but your A inverse. So that is how you find the inverse of a matrix. Okay. So let us see an example. Inverse using elementary row operations. So inverse using what? Elementary row operations. So A is given, that is 1, 2, 3, 4. See, one of the ways to find out inverse is find the determinant, then find the adjoint, and then 1 by determinant multiplied by the adjoint gives you the inverse. But here we are going to do some row operations. Now we will write A as AI. So A is already there and I, like this. So let me split it. This is your A and this is your I. Now we'll try to convert A into I. But to convert, there is a pattern. Firstly, make the first element 1. Then try to make the second element over here 0. Then you make this element 1. And then finally, you make this element 0. So you move like this. This is first, this is second, this is third, this is fourth. Don't hamper the order. Please make sure that you keep this order only. So let us try to make the first element 1. But it is already 1. So this job is already done. We don't have to do anything. Now I want to make this 3 as 0, because if I want to convert it into identity, this should be 0, no? So we will do some operations here, row operation. So we'll try to find some connection between R1 and R2 such that this element becomes 0. So can I say R1 is 1, here R2 is 3, I want to make 3 as 0. So if I multiply R1, by 3, what will happen? That becomes 3, because 1 3s are 3. And then if I subtract R2 and R1, if I subtract later, R2 minus R1 multiplied by 3, can I say 3 minus 3 will give me 0? So that is exactly what we are going to do. Now understand. So what I am doing is, R2 we are changing by taking R2 minus 3 R1. R2 minus 3 R1. Now understand, what will happen is, if you see this, R2 minus 3 R1, this becomes 0. But this is R2, this is also R2, this is also R1. So I need to do it here also. Don't forget to do it here. So 4 R2 minus 3 R1 is 2. So 4 minus 3 into 2, 4 minus 6 is how much? Minus 2. That is why we have minus 2 here. I hope this part is clear, right? Now understand, here how did minus 2 and 1 came? R2 minus 3 R1. So now further what we are going to do is, we need to make this 0. So we'll do R2 minus 3 R1. So this becomes 0. Apply it here also and apply everywhere here. So further you are going to get this. Now to make this as 1, what are we going to do? We are going to multiply it by minus half. So this becomes 1. Here also we are going to multiply by minus half. This becomes 1. Here we are going to multiply by minus half. This becomes minus 1 by 2. Now the only thing is, this we need as 0. So R1 minus 2 R2. So let us do R1 minus 2 R2. So this will be 0. R1 minus 2 R2, R1 minus 2 R2. This changes to minus 1 and 1. And then this is I, and this is some matrix. I into any matrix is the same matrix. So here you are going to get this as it is, and this is nothing but your inverse. So in this way you can find the inverse of a matrix using the row transformation. Now let us see an example here. So matrix A is 4, 7, 2, 6. Find if matrix A is invertible. If yes, calculate the inverse A inverse. So if matrix A is invertible, we are going to calculate the inverse of it. How do we do that? And how do we check whether matrix A is invertible or not? We know that a matrix is invertible only when the determinant of A is not equal to 0. So let us see. So firstly we'll find out matrix A and its determinant. So how do we find out the determinant? 4 multiplied by 6, 7 multiplied by 2, 4 multiplied by 6 here, 7 multiplied by 2 here, we subtract, right? So that gives you 24 minus 14, which is 10. Okay. Now understand, is 10 equal to 0? No. 10 is not equal to 0. Since it is not equal to 0, we can say that the inverse exists. The determinant is not 0. So the matrix is invertible. Clear? Now how do we find out the inverse? 1 by determinant of A multiplied by the adjoint of A. So 1 by determinant of A. So this is anyways 10, right? We already know. And we know how to find out the adjoint. We have interchanged this and we have taken the signs. Let us do that. This becomes, the adjoint is here basically. So put the adjoint here now. So 1 by 10, and then this is the adjoint matrix. So this matrix is what? What is 10? 10 you know, it is the determinant of A. Now we will multiply 10 inside with each and every term. So what will happen? This becomes divided by 10. So 6 divided by 10 is 0.6. Minus 7 divided by 10 is minus 0.7. This is minus 0.2 and this is 0.4. If you want to keep it in fraction, you can do that. 6 by 10 minus 7 by 10, 2 by 10 and 4 by 10. That is also fine. So in this way, you can calculate the inverse. Now, let us see an example. If A is a matrix 2, 3, 1, 4, 5, 2, 6, 7, 3, determine whether the matrix A is invertible or not. If it is invertible, then find the inverse of matrix A. Now again, what are we going to do? We are going to find out the determinant of A. If the determinant of A is 0, it is not invertible. If the determinant is not 0, it is invertible. But this is a 3 by 3 matrix. So how do we calculate the determinant? We need to understand that. So whenever we have a 3 by 3 matrix, what we do is, you pick up any row and you expand that along row by taking plus, minus, plus, alternate plus, minus. How? I'll tell you. So first row, what are the elements? The elements are 2, 3, 1. Pick up 2. Pick up 2. Now 2 belongs to first row, first column. Remove that row and column. Remove it. What is remaining? 5, 2, 7, 3. Take the determinant of that. 5, 2, 7, And you know how to solve this part. So this plus is done. That was your 2. Second is minus. That is this number. So write down minus 3. Now that is first row, second column. So remove the row, remove the column. What is left? 4, 2, 6, 3. Write down here. Clear? So minus is done. Then now you have plus. So for that, what you can do is third one, right? This one. Take 1. So write down plus 1. Remove this row, remove this column. What is remaining? 4, 5, 6, 7. Write down here. I hope this part is clear to you. So that's how you solve it. So let us see here now. So we'll move on to the solution. As I told you, the same thing, whatever I wrote, it's here only. Now you know how to solve this part, right? So solve it further. So this becomes 2 is as it is, 5 multiplied by 3 minus 2 multiplied by 7. Minus 3 as it is, 4 multiplied by 3 and 6 multiplied by 2. And then plus 1 as it is, 4 multiplied by 7 and minus 5 multiplied by 6. That's it. So if you solve this further, you get the answer as 0. And your answer is 0, that is the determinant is 0. So we can say that the given matrix is not invertible. That means we cannot find out the inverse of this matrix. So I hope you have understood all the concepts based on matrices. We have studied a lot of concepts. We studied what is matrix. We studied about types of matrices. Here we have studied how to find out the inverse. We have studied how to find out the transpose. We have also seen that AB inverse is equal to B inverse, A inverse. Then we also saw how to find out the determinant, right? Also saw how to find out the adjoint and the basic formula, that is to find out the inverse, which is 1 by determinant of A, adjoint of A. I hope you enjoyed the session. See you next time. Thank you.